Awesome. Welcome, everybody. Having a great time? Very cool. So how many of you are in a food coma after lunch? Cool. Well, let's get rolling. We'll keep some of the doors open to let people come on in, but we're going to get started. So this is right-sizing your SQL Server virtual machine, kind of a 300 level, but we're going to ramp people up with a lot of the infrastructure topics that we're going to talk about. Because I know from a DBA standpoint, we generally don't have a lot of hands-on experience with infrastructure or virtualization or a lot of those technologies. So I want everybody to know the talking points, the terminology, the concepts, and that way we can really hit the ground running when you go back to work next week, and that way you can really get some major improvement there. Okay, so show of hands. How many of you have the majority of your production environment virtualized today? How many of you are happy with the performance? That's better than I thought. That's, for those of you that raised your hand, that's great. Now, how many of you are interested in fine-tuning this to make sure you get the peak performance at all times? Awesome. So now, common scenario. I want more resources. I want more RAM, I want more CPU, I want more disk speed, right? How many of you fight your admins and they want to take some of this away? At the end of this session, you're going to have all the ammo you need to go back and tell your admins, maybe I need that, maybe I don't. Let's do this with numbers. Numbers don't lie, usually. So what's the right answer? That's what this entire session is about. So what we're going to do, I'm going to save a lot of the Q&A for the end. And actually, if you're on Twitter right now with PASStv, this is being broadcast. So I'm also going to take some questions from there as well. And let's get rolling. So my name is David Klee. I'm a certifiable nerd. I do a lot of infrastructure work. I do a lot of virtualization. I do a lot of SQL Server performance tuning, HA, DR. Lucky enough, I've gotten Microsoft MVP this year for the first time, and I got VMware vExpert 2 years in a row. If you want to contact me, I open myself up. Any questions you have regarding this topic, it's one of those areas that not a lot of people really focus on, but it impacts all of us. So there's some contact information up there. Feel free to reach out and let me know. Let me know what I can do. Okay, just a little bit of housekeeping. Please make sure your cell phones are turned off or set to vibrate. And make sure to take full advantage of this conference. Not just the conference, PASS as well. The PASS organization is great. I co-lead the High Availability and Disaster Recovery Virtual Chapter. I contribute a lot to the virtualization and performance chapters. They're a lot of fun, but SQL Rally, SQL Saturdays. How many of you have been to a SQL Saturday? Very, very cool. Those of you that haven't, check them out. They're all over the world, all over the time. It's great. So evals, if you think I stink, please tell me why, but please fill it out. I really do want your feedback. I love this topic. I love to get up and speak like this, but all of our speakers are always looking to do better. So be constructive, be honest. We want to hear it. Okay. So what we're going to talk about today is what is virtual machine right-sizing, and why do you want to do it? We're going to talk about the individual pieces of the system stack that you really do need to get access to and start to performance profile. It's collecting data, it's analyzing the metrics in a couple of different ways. We're going to talk about specifically the stuff that matters the most to DBAs, CPU, memory, and storage. Networking is in there too, but usually that's not that big of a deal. We're going to take all of that and show how to go analyze the environment, and then we're going to figure out really the workload properties of your environment. What are the pros? What are the cons? What is this thing actually doing? And then we're going to talk through taking this info and doing something with it. Okay. So first of all, how many of you have gotten hands-on with your virtualization hypervisor? That is a great number. Usually it's about 1 or 2 hands. So from a high-level perspective, just what is virtualization to begin with? You know, a lot of us, it's something that the admins came to you and said, you're getting virtualized next weekend, and then they walk away. And that's all you see, that's all the access you get, and it doesn't have to be that way. But fundamentally, just what is virtualization? It technically is an abstraction layer that separates the dependency of the hardware from the operating system and everything running on it. Realistically, it's just another operating system that runs under the covers that does all the magic. Now, functionally, from a high level, what virtualization really does is it transforms that physical machine into a collection of compute resources. So CPU, memory, network, and disk. And it gives you queues to get to them. You can run multiple independent operating systems on the same physical machine. Every resource, so CPU core, bit of memory, whatever, there's a queue to get to it. So if you take this concept of queues and resources, free your mind of a lot of the stuff, of a lot of the constraints of the physical machine, and a lot of the stuff will really start to make sense. Now, like any environment, there's going to be limits. You know, there's limits in the environment. There's hard limits, like resource limitations, like memory consumption, or my storage can only perform so fast, or an individual CPU core runs at X number of gigahertz. Those are easy to detect. Those are easy to compare against. Those are easy to go through and plan for. There's also soft limits. For example, queue contention. As a feature of the hypervisor, I can go through and allocate more virtual CPUs than I have physically available. They all go through those queues. How long does it stay in the queue? That's a soft limit. It's a moving target, and they're silent. That's the complaint. Right sizing is figuring out the correct number of virtual machine CPUs and memory and disk configuration that matches your workload. Just a quick example, how many of you have fixed assignments in your environment for VMs? Database server, 4 CPUs, 16 gig of RAM. Well, one size doesn't fit all. For example, about 6 months ago, I worked a really big project where I had a 40-core virtual CPU, or virtual machine CPU, that was running slow, quote. I got a real good look at some of the metrics, and they didn't really laugh when I said, I got a faster SQL server right here. We turned the machine off. We knocked it down to three CPUs from 40. Doubled the performance. It sounds weird. It sounds hard to believe. But allocating too many resources to a virtual machine, if it's not actively using all of them, or if there's a lot of background contention, it can actually slow the VM down. And it's a silent performance hit. You're not going to see it in an event log or a DMV. All you know is stuff is just running slow and you don't know why. It's tough. The stuff to care about, it's virtual CPUs first and foremost. Memory's a lot easier to size, but it still matters. And then storage presentation. Now, storage performance is generally a fixed thing. But you've got a lot of pieces in between those disks in your data. So we're going to talk about all those different layers. The hard part here is for those of you that raised your hand with the one-size-fits-all workload, that doesn't work. You may be over-allocating, you may be under-allocating. We're going to talk through how to go through and really look at that and see if that's really the right thing. Now, some examples of these resource limits. The hard resources, a single physical machine's limits. X number of CPU cores at 3 gigahertz and let's say 128 gig of RAM. Realistically, you can't exceed that. Now, the total cluster capacity, if I've got, let's say, 5 of these physical machines in a VM compute cluster, you can't go allocate machines you can't allocate VMs that really exceed one of those physical machines' limits. And you can't start adding machines that really exceed the entire cluster limits for memory there specifically. Storage speed, IOPS, throughput, latency. These are hard limits. It's generally a lot tougher and usually a lot more expensive to work around that than some other things that we can do. And then VM maximums itself. Modern hypervisors today have physical limitations within the OS of the hypervisor. For example, the biggest VM you can build today is 64 CPUs and a terabyte of RAM. Now, if you can't virtualize it in that, call me, because I want to know what you're working on, because that sounds cool. Under the covers, there's also some things, like the number of interconnects that you have between your physical machine and the storage and the networking. You've got bottlenecks in there. Now, there's some tricks you can do to work around that, but it's still a limit. Now, the soft limits get a little more interesting. Memory over subscription. It's not a bug, it's a feature. You can allocate more memory than what you have physically present in that physical machine. The hard part is that most VM environments are designed with this in mind, but you know how hungry SQL Server is for memory. You know, you give it 100 gigs of RAM, if you've got that much data, it's going to hold on to every last bit of that. So it's understanding the crossover between SQL Server and the VM environment. The CPU scheduler contention is one of those that gets really interesting real fast. We're going to talk through what that really means. And then shared resource utilization. So from a traditional standpoint, as a DBA, I want the machine. It's mine. I'm not sharing anything. I want everything this machine has to offer. With that physical machine now handling multiple operating systems, multiple VMs, it's shared everything. And that's a hard concept to really grasp. And it's hard to actually give that up. The question is, where's that limit on how much we give up versus how much of a performance hit we take? So we'll talk through that. And then variable resource utilization levels. This gets interesting. So, for example, what if another virtual machine on the same physical machine just kicked off a SQL Server backup? What does that do to the performance of the machine I'm currently interested in? You know, is the backup consuming all the network? Is it consuming a lot of the CPU? What about the paths to storage from having to read all of that? There's a lot of different options in there. So we talk about resources and queues. So realistically, from a fundamental standpoint, this big set of physical machines, now I've got resources that I can start to carve up. So in this case, CPU, memory, network, storage. I've got the virtualization layer that's on top of all these machines, and they're joined together to run as one big compute cluster. And now I can start carving up VMs. All VMs are not created equal like this. Gets interesting. Because what's really under the covers of the hypervisors is actually the resources and the queues. So for every physical machine that's got a hypervisor on it, you've got multiple queues to get access to anything. The big ones, again, CPU, memory, disk, network. So what if I'm chewing up this path right here for a backup? Well, the disk queue inside the hypervisor is going to start to back up. It can't get to disk fast enough. Hard part there is that's time spent not handling what the virtual machine is doing, and that can affect more than one virtual machine. Whatever's accessing that LUN is now going to have latencies of disk start to rise. And that's tough because it's silent. You don't know what's running on the background. Now the goal here, any one of these weights inside this environment is going to slow you down. Sometimes it's measurable but not noticeable. Sometimes it's really severe. It's tough. The goal is to minimize these weights and make your stuff run as fast as it needs. So again, the resource limitations, the physical, the hard layer, easy to detect, fairly easy to work around. These queue contention layers, it's tough. So we're going to talk through from a SQL Server DBA standpoint how you can actually see a lot of this and what you can do with it. Yeah. Biggest thing, everything that goes on in that VM has to be scheduled. Has to go through these queues. It can't go direct. That's where things get fun. One note, queue processing inside those schedulers is not necessarily handled like a queue. It's not necessarily first in and first out. Stuff can be deprioritized. It can get pushed to the back. Other things can cut in line. And again, from the standpoint of the DBA, we don't know what's going on under the covers. It gets interesting. So I've got an example here. Now this is a very, very exaggerated example of what's going on under the covers. But this happens. So I've got my SQL Server virtual machine that's just running happily along. I've got a parallel query. Very simple. And I got 4 virtual CPUs on this VM. This is the CPU processing by core. So every one of these has to get scheduled. Now each one of these, that's your scheduling queue. So it's not always linear. Something in a virtual CPU may not get executed at the same time as something else in another queue. Hard challenge there is SQL Server is dependent on all of these threads getting handled, and then it comes back and returns the result set. So if you look, the green here is when it actually gets run. The blue is a queue. That's my query end time. How much time did I just lose? These gaps in the processing, that's your scheduling queue wait. These waits can add up. And at the end of the day, if you've got really, really high CPU scheduling contention under the covers, and it's a pure design of just your VM admin just putting too much on that environment, it's going to add up. All of that adds up, especially with another query and another query and another query on this VM, and then the same exact thing on 100 others. It adds up. Now, if for some reason you got really high CPU scheduling problems like that, sometimes, not all the time, if you cut back the number of CPUs, it can actually lower the load. The time gaps between when these things get processed get cut down because it's easier to squeeze these in. Now, the individual duration of those chunks may grow because you have less processing power there, but the end result might actually be time saved. For example, I had one where we had that 40-core environment. It cut way down. There's another one. One VM, one physical machine, dedicated SAN, nothing else on it. We turned the VM on with 8 CPUs. We had an 8 CPU synthetic workload, fired it up, it ran great. Turned it off. Reconfigured the VM for 32 vCPUs, turned it on, restored the backup, did the exact same test. And guess what it did? 21% slower performance. Now, it sounds weird, but here's the technical reason why. Windows, under the covers, detected 8 CPUs of SQL Server going berserk. And it goes, I need to dedicate all of this to that process, SQLServer.exe. So it took everything else in the OS and shoved it to these other 24 CPUs, including things like I/O handling underneath the SQL Server to fulfill the request, and network handling to get the request back to the application server. The hypervisor detected the 8 really, really high CPUs and kept cutting those in front of the line. But the problem was it was cutting ahead of the request to actually go get the stuff off of storage or handle the networking request. So the whole thing slowed down. We dialed it back down to 8 CPUs, turned it on again, ran just fine. So these idle CPUs, with the way the hypervisor is not aware of what the operating system is doing, nor is it aware of what the application is doing, can really bite you. It's really fascinating looking under the covers at a lot of this stuff. But I'm a geek. I made peace with that a long time ago. So how many of you do ongoing performance metric collection in your environments today? What's the retention like on there? Is it pretty good? Or what do you do with this data? I mean, do you trend it? Does it sit there until you have a performance problem, then you go back and look at it? What's actually done with it? This is one of those critical things that if you have not done this before you virtualized, after you virtualize it, you have no basis for comparison to say, I'm running 10% slower after I virtualized, or 50. Because, we're the DBAs. We're the default blame acceptors. What do you get? Somebody comes up to you and says, it's running slow. It's got to be your database server. And then what do? Well, virtualization's the new kid on the block. It's got to be virtualization. It's not the code release from yesterday or the SAN problem they had last week. None of that. The hard part there is proving it. I don't care where the problem is. We all need to work as a team and find it, because at the end of the day, the application is what really matters for the business. So it's finding it quickly. Now, these performance stats, they're so insanely valuable. I don't care what you use to actually go collect this, but you need to use it. Collect, so Perfmon, SCOM, SolarWinds, whatever utility you've got, get it up and running. Because you have to collect the stuff from every piece of the stack. As a DBA, you have visibility into a lot more than you think. You can see what the storage is doing out from underneath your SQL server. Sometimes you can see the properties of that physical server, be it virtual or physical. You can see what the CPUs are. You can see what the architecture is. You got the virtualization layer that you may not have direct access to, but with the right terminology and the right discussions with people, You can get at least read-only access to it, and I stress that you do. You've got interconnects that connect all this stuff together. You got the operating system that can be tuned a little bit, and it's not huge. You got the SQL Server instance that you can get a lot of tuning out of. You got the database server, where we generally think of as the only place that we can really tune. But if the infrastructure underneath is garbage, you can tune away. You're not going to get a great result. And then you got the application. All of this stuff we need to collect metrics out of, because you can put all this together and get a great picture out of it. Now, what do we actually want to go collect in order to figure out what the virtualization layer really needs? Every layer, from SQL Server itself, just raw CPU memory disk consumption. So, CPU by core, memory consumption stats, such as page life expectancy, signal weights, all these things that give you a concept of what's really going on. NUMA memory usage. So you can actually go see what your memory stats are by NUMA node. And I'll talk about NUMA node here in a minute. Signal weights, storage latency by database data or log file. That really comes in handy, because now you can start to see hotspots. And you can see if my load really increases on this particular spot, what does the latency do of that physical machine? What's the latency do of the storage as it relates to SQL Server? And then a lot of wait stats to tell you what SQL Server is really waiting on. If you want to get started with this kind of analysis, Glenn Berry's diagnostic scripts are my starting spot. They are phenomenal. There's a link right there on the screen to go get them. It's just at SQLskills.com. He's here at the show. Find him. The guy is amazing to talk to. Now, from within Windows, there's a lot of things that you can get there as well. Again, CPU and memory consumption, because CPU consumption in Windows may not necessarily line up with CPU consumption just in SQL Server, because there's background things running, like monitoring agents, or antivirus scanners, or, heaven forbid, things like disk defragmenters, or a lot of the background stuff that system administrators generally install on the machines to do centralized management. Storage metrics, you can get through anything that does WMI monitoring. So you can go by drive, give me IOPS, latency, and throughput. We'll talk about that here in a little bit. Processes. If something else is running in the background, I want to know what it is. So WMI can get this. And then perfmon. Now, for those of you that don't have an ongoing performance metric collection set up today, you've already got one. It's built into Windows. It's called perfmon. There's a lot of guides out there for how to go set this up, but I've got one out at my home blog site, just davidklee.net, and I walk through how to set up perfmon end to end to go collect all these metrics that we really care about. There's also a couple of gotchas that I handle at the end of the script, such as if I reboot the machine in the middle of the day, a lot of the other ones run for a day and then stop until midnight that night, so I go and clean all that stuff up. Now, the guide out there tells you to do every 5 minutes. If the machine is problematic, or if you really want to focus more granularly, drop that threshold down. Just make sure the performance impact of it isn't going to hurt you. You can go all the way down to 15 seconds or so. And what do you do with all that information once you get it out of perfmon? The Midnight DBAs, and they're here as well, they actually have some sample code out there to go take those perfmon data files and extract them and automatically get them into a database, so we can do what we do and go get that information back out. Capture all of your metrics as granularly as possible. And what do I mean by that? Let's say I've got 40 CPUs in my SQL Server. Do you want an average? No. Because what if my average says 3% CPU consumed? And what if 39 of my 40 CPUs are idle and one's pegged out all the time? That average isn't going to tell you that. The same thing with disk. So with any of these utilities, you have the ability to do by core, by NUMA node for memory, by drive for disk, all this stuff. Get it as granularly as you can. And again, if you need to really reduce the monitoring window to get more accurate, do it. Just make sure the performance impact of it doesn't hurt your machine. Now, virtualization counters get interesting really fast, because some of these things we don't have direct access to. Some you do. You may just not know it yet. So resource consumption by virtual machine per physical machine. You probably don't have access to this one, but all you got to do is go to your VM admins and say, I need read-only access into the management system for my hypervisors. Just give me access. Let me see what the stats are on the machines that power this database server and my machines. And you can go, you should be able to get access to it. If you don't, let me know. I'd be happy to help out there because this kind of access is absolutely critical to us being able to do our job properly. Resource consumption by host. So what if you've got a physical machine that's running at 100% CPU? Well, you know there's a problem there. If you wonder why something's running slow, you go hit the VM management system, 100%. Well, you can stop right there, go to your VM admin and say, problem. You know. CPU scheduling queue waits. Now, I've got a whole laundry list of topics to go on there. This isn't that kind of a session. But inside Hyper-V and VMware vSphere, you can actually go monitor how long a virtual machine CPU task spends in that queue. On VMware, it's called ready time. On Hyper-V, it's called CPU wait time per dispatch. And all it is, all those gaps in that graph that I showed there, all it is just that aggregated. It says how many milliseconds you just lost in performance on that polling interval for that metric. So I've got blog posts all over the place about that. Go check it out. Email me if you have any questions at all about those. Overcommitment metrics are also another one. You know, what if I have 10 virtual machines on this physical machine? I got 64 gigs of RAM in the physical machine and 100 gigs of RAM given to that the set of VMs. Well, you just overcommitted your memory by a lot. It's not necessarily the best thing to do. It's not necessarily the worst. Well, with SQL Server it is, but you know. So storage. It's a big one. Now, we don't generally have direct access to the SAN, but you can get all these numbers. I already mentioned them. The stuff that I care about, IOPS and latency. Generally, latency first. Latency, it doesn't matter how fast your storage is. If you have high latency, it's going to kill you. IOPS, throughput. Generally, you can get it by drive, which usually corresponds to by LUN, by disk group, by controller. You can go get that from your VM admin. And then path consumption. Again, work with your infrastructure folks. You can go get those. Controller cache hit metrics, and again, capture all this stuff as granularly as possible. Now, how do we want to analyze those? You overlay everything, and I'll show you what I mean here in a little bit. The thing to classify before you start collecting and really analyzing this stuff is understand what are my workload periods like. For example, I generally look at CPU stats across a full business week, usually Monday at 8 a.m. to the following Monday at 8 a.m. But I don't want to just say, here's my average, because what if you've got weekly processing that runs on the weekends or backups that run at night? You know, if I want to see the business day impact to this, I generally want to say, hey, well, here's my averages for the day. But now here's my averages for the business day, you know, say 8 to 6, Monday to Friday. Or what if I've got a really heavy workload period, such as if I'm an e-commerce site and it's, you know, between Christmas or between Thanksgiving and Christmas. That's going to be way different than if you're, you know, right around the 4th of July. Big difference. The workload sources are also really, really interesting. You know, what if I've got multiple machines that have completely different usage patterns? You got data all over the place coming in. Some of them can have high networking activities. Some are just high processing. Gets a lot of fun. Now, the goal is to get every relevant metric by time period. And that way you can start to see the impact. Because sometimes a maximum number may not necessarily give you the whole picture, especially if that's just because a backup was running at night. Now, the stuff that I love to do with this, once you get these metrics, is start to do a median and percentile analysis. Because again, an averages, you know, min, average, max, doesn't necessarily tell you the whole picture. So this helps you explain away some of the statistical phenomena, like a disk latency spike at 2 in the afternoon that happened for a quarter of a second. That would throw off an average really, really bad. In this case, you can start to explain some of that away. You don't have to worry about going and getting a degree in statistics either. I got a lot of the queries up here that I'm going to share that will help you do this. So stats, min, average, max. Median is also very important there because it's not necessarily the average that we're worried about. Percentile analysis is a big one. So now let's go a little bit deeper. For virtual CPUs, what do I want to do? The counts matter. They really, really, really matter. The goal is size this environment for what you need today, not necessarily what you need 2 years down the road. You know, if I were to go buy physical equipment today, I'm going to get the biggest machine I can afford, and it's going to last 3 or 4 years, and it'll age out. And most of the time, all those resources are just idle. Everything's got to be scheduled. So if you go do that with a virtual machine today, and they're just not actively used, it's going to hurt you. And chances are you're not going to grow into that full machine over time anyway. So size today. Too many CPUs, most likely it's bad. Now, if you've got one VM to one physical machine, no big deal. It happens. Too few CPUs, obviously that's really bad because we just need more to handle the workload, and the business is going to suffer as a result. Very, very, very workload specific. Now, NUMA, I mentioned this before when it comes to memory. SQL Server is insanely NUMA aware. And what do I mean by NUMA? So a long time ago, you had, let's say, a 4-slot physical machine with 32 gigs of RAM, and that was just state of the art. You know, extremely expensive, just awesome. Well, over time, CPU densities went up, memory densities went up, and they found that that interconnect between CPU and memory was a bottleneck, and it just couldn't keep up. So what they ended up doing was they actually split the memory across the CPU sockets. So they've got a bank of memory really close to a CPU socket, and that way it's, you know, just tiny amount of distance that that request has to travel, and therefore it's going to be faster. And they did this for every CPU socket. Now, one CPU can access memory on another CPU's bank, but called a NUMA node, but it's more expensive because it has a farther distance to travel. It's got more hops to go through. So SQL Server is insanely NUMA aware, and they did this because the operating system extends this knowledge of proximity to the applications. Smart coders can code for it, and they did a great job with SQL Server. What you can find here is that if I can fit a virtual machine inside one NUMA node, it's going to run really fast. By default, if you just you right-click Create VM, it's going to set this up where the memory and the CPU threads just may be all over the place. It's not necessarily the most efficient. So when you start building bigger and bigger SQL servers, and I generally go at about 6 CPUs and up, you want to start to understand what that physical machine is that it's going to live on, because that changes how you construct the CPU assignments. It gets really interesting, makes it more efficient, and it's going to give you better performance. And I can show you that here. So first of all, get the physical machine configuration from your admins. It's really simple. Is it a 2-socket machine? Is it a 4-socket machine? What kind of CPUs do you have? How many cores do they have? That's basically it. Straightforward, basic. Try to fit the VM inside one node, balance accordingly. Let me show you what I mean by this. So let's say I have a 16 virtual CPU VM. That's a pretty good sized SQL server. Well, what's better? 4 virtual sockets by 4 virtual cores? Or 8 virtual cores on 2 sockets each? Or the other way around? In theory, it sounds like they should all be equal, right? So poll of hands. Who thinks the 2-socket by 8 core is better? Who thinks the 4 by 4 is better? Who thinks the 8 by 2 is better? Who wasn't listening? So the fun part here is a standard DBA answer. It all depends. What's the physical machine like? What's the workload intensity like? What's the hypervisor going to do as the load goes up? And the really cool thing is you can go test this today. So if you've got your workload out there, if you have some ability to replay the workload, go test. Straightforward, easy to do. Work with your VM admin. Turn the VM off, change the CPU configuration. Turn it on, run your test. Turn it off, change the configuration again, do it again. And it's really interesting what happens. So if you look at this graph here, this is a Hammer DB, and if you do a Google search for Hammer DB in SQL Server, you'll find that Mike Fowle wrote a really good article of how to use this. It just simulates the TPCC benchmarking stack. And what we did was we ran some tests on each of these 3 configurations at varying degrees of workload intensity. And we found that over time, as the workload intensity went up, the actual performance of the VM per configuration changed. So at the very beginning, when it was just idling, it was almost identical. Right around the 64 active threads, we found that we had a pretty substantial gap in performance. That's a 31% performance improvement on my SQL Server just by clicking 3 times and hitting OK. You'd never know until you tried it. Workload specific, it took more time for me to plot and graph this stuff than it did for us to do the test. 31% performance improvement with 0 code changes. Yes, sir? The question was, what is the physical machine configuration of this? And that's a great question. That's a great question. I was hoping somebody would ask that. The physical machine configuration in this specific test was a 4-socket by 10-core physical machine with ½ a terabyte of RAM. And again, it all matters. Every piece of that, it's all completely different to your workload. 31% performance improvement with 0 code changes. You show your boss how to do this, you will be a hero. And again, 1 maintenance window, a couple of hours, done. So the exact metrics to go in and actually prove all this, one is just runtime. You know, if you've got stuff that runs a lot better at different configurations, just time it. Simple as that, real straightforward. The stuff that I look for, CPU consumption by database. I look at the top weights. I look at signal weights. Anything that shows CPU pressure inside SQL Server. Now, there's a running argument in the SQL Server community about how do you go set the max degree of parallelism and how do you go set the cost threshold for parallelism. Well, there's a lot of really good advice out there. There's a lot of really bad advice out there. And I don't have any specific numbers for you because it all varies by workload. It all varies by hardware configuration. And one of the things I do is I actually will scrape the cached execution plans, and I'm going to go look at that parallelism threshold value that's calculated per execution plan. I'm going to go sample this. This is a link, I believe, off of Jonathan Cahias, and he's got the query up there. So you can go pull this and go see where are my actual parallelism thresholds at for my workload. I'm going to go tune that. Because the reason I bring this up is that the goal is scheduling less on the physical machine as wide while maintaining performance. If you can go tune that value, you may be able to do better. Inside Windows, again, CPU usage by core. SQL Server versus background activity is a big one. The virtualization host, if it's running over 80% CPU consumed, that's a problem. If the VM CPU queue waits, so again, CPU wait time per dispatch or CPU ready time, you work with your VM admin, you can go get that. Now, how to size this stuff? It's, to me, when it comes to sizing CPUs for SQL Server, when it's virtualized, it's all about the workload intensity, and it's about how parallelized that set of queries really is. You know, for example, if I've got SharePoint, they make you run without parallelism. So you want the fastest possible CPU cores in there. The wider you go, it's not going to help. So if your workload doesn't demand it, you know, so be it. But then other applications, you may be needing all 40 cores, and I'll show an example of that. Again, determine the averages, maximums, and the percentiles. Determine the appropriate profiling period is an interesting one. Again, we talked about that, but what if I just want to run during nightly execution of a batch process versus an entire day? Just get that window right. Generally, my rule of thumb is if a SQL Server VM is running less than 40% consumed across the board, you know, and that's if there's a decent workload on it. I mean, if it's just a utility server, you know, a couple of CPUs and you're good. But if you've got less than 40% consumed, you probably have too many CPUs on there. If you're above 60, and again, it completely varies by workload. If it's over 60 all the time, not just a spike, you may not have enough. So we're going to show some use cases of that here in a little bit. Factor the CPU waits, because if the code is bad and it's constantly waiting on CPU, you may want to tune some of those dials a little bit more. And again, it's really, really easy to go fix this, to go test it, evaluate it, and see what's best. Okay, memory, a lot more straightforward. We know that for SQL Server to process data, it's got to be in RAM. So therefore, we all want all the RAM we possibly can get, right? Well, generally speaking, more memory means less I/O. It's going to be in RAM. Most OLTP machines are, 85, 15% read-write. We want to have more memory to have less I/O. Simple as that. Well, less I/O, less waiting on shared storage. shared interconnects, shared processing, and those shared queues. So in some cases, less CPUs and more RAM might actually benefit you better than more CPUs and more RAM. Now, this is something to take back to your VM admin. 0 physical machine memory overcommitment, period. It gets interesting. What happens is, it's a feature. The virtual environment, they were originally built for consolidation. So what happens when you consolidate memory? Because, a web server might only use half the memory given to it. SQL Server, it's going to consume all of it. If you dump your mission-critical SQL servers in one of these general-purpose environments that's built for consolidation, you are probably overcommitting on RAM, and therefore, SQL Server thinks it's in RAM. The hypervisor actually drops it back to disk, or is trying to compress it or dedupe it, things like that, and you get bottlenecks. So again, silent. So just check with your VM admin and say, for my SQL servers, 0 host memory overcommitment at all. Because memory is cheap. SQL Server licensing isn't. Now, again, too much virtual machine memory now. If you've got a page life expectancy measured in decades, well, you've got everything in RAM, but you just hurt your consolidation ratio, which again drives up licensing, which makes your boss mad. That's not exactly a good spot to be in. It's this really, really tough balancing act. What's the right process there? So again, the metrics. Everything inside SQL Server that matters when it comes to memory pressure, sample and do the stats on it. And we'll show you this. PLE, cache hit ratio, page fault count, recompile, resource semaphore weights, memory grants pending, anything that matters. Anything that really shows memory pressure or memory thrashing, page faults, whatever. There's tons of stuff. Megs free within Windows. If you're actively paging to the swap file, that could be a sign of a problem. Just keep an eye on that kind of stuff. Again, perfmon will tell you all this. At the physical machine, again, no memory overcommitment. You get bad things with that. It's called memory ballooning or dynamic memory expansion. All this stuff can cause pressure, which cause issues. Okay, so now, realistically, how much memory do you really need to get your SQL Server to process properly? Again, I can't tell you the magic number. I really wish I could. But what do? You got slow storage, it's cheaper to add more RAM. If you got really fast storage, what's the difference in a 1/10 of a second versus a 1/15 of a second on a page click in an application? Generally, not that much. Now if that's executed a million times a second, that could be a problem. But faster storage, especially all flash arrays today, you might be able to get away with less RAM. Now, more RAM, less consolidation at the licensing level. And again, if you can dial this stuff back just a little bit, you may be able to save your boss $100,000 worth of licensing, sometimes even more. It's pretty crazy. You can also do something that you have control over. You can do table level compression. You can do index compression. It's a lot of fun because I can potentially use, let's say, 5 to 6% more CPU if you've got it sitting there, to do 30 or 40 or 50% less I/O. Makes a big difference. Now, storage is one of those things. How many of you feel like your storage is a floppy disk? When it comes to virtual SQL servers, storage is the single biggest problem. It really is. It's tough because it's out of our control usually. Other people manage it, and it's fixed. We have a really hard time adding resources to it, expanding the capacity, things like that. It's tough. It is the most shared resource in this environment. Everything is running on that SAN. Therefore, it's the most critical. How many of you have had a SAN failure before? For those of you that haven't, consider yourself lucky. It's easily the most complex device in the stack. Usually it's the most problematic. If you call any of the hypervisor companies out there and ask them for the single biggest challenge they've got, one of the big ones is going to say 80% of our problems with virtualized business critical apps is going to be storage. Simple as that. Hard part here is you look at how fast some of this stuff runs. So it's the most complex, the most expensive, the most problematic, and it's the slowest. Well, that stinks. So what are you going to do? The hard part here is, we talk about random or sequential I/O. Realistically, if I've got a lot of SQL servers and a lot of different VMs accessing the same SAN, every single thing that's actually hitting the SAN is going to be completely random. So you got to tune it for it. It gets interesting. Now, how many of you have actually dug into the underpinnings of a SAN? There are so many points of contention in here. And this is one of those areas that, how many of you have actually ever had the argument from a VM admin, it's the same set of disks under the covers. Why do I need to have multiple drives for SQL Server? For those of you laughing, you know where I'm going with this. It's not just the disks. There are queues in so many areas, excluding the hypervisor. You got Windows I/O queues just inside Windows. You got the queue inside the hypervisor. You've got the queues getting out of the HBA or the network adapter in the controller. You got stuff inside the switches that may not get where it needs to go. You got the interconnect on the SAN itself that may get backed up. You got CPUs and memory inside each controller that can choke. And then finally, then you hit the disks, which aren't configured fast enough. It gets interesting. There's very little that we can do with a lot of this directly. But what you can do is actually evaluate your storage to go see what's really going on. See how it's running as it's presented to you, not necessarily how the SAN guys have it configured, because who cares about that? We need to know what is actually hitting it today. So there's two utilities I love. SQL IO Batch is a PowerShell script written by Niels Grove Rasmussen that takes the free utility from Microsoft called SQL IO and actually goes and will iterate through a lot of different performance patterns in there. And then he's got another PowerShell script that will get that information out into a CSV file so you can actually graph it and chart it and see the picture of how the storage responded to a lot of the activity. And there's another one that Microsoft just put out on GitHub just a couple of weeks ago called Disk Speed. I'm looking at it as a replacement to SQL IO because SQL IO's been out there for quite a while. Again, they both do the same thing. They're command line utilities that you throw some flags out there to say random or sequential, workload parameters like the thread intensity or where to place a file or how big to test, and then out comes a number. The stuff that I care about, IOs per second or IOPS, kind of like transactions per second in SQL Server. It's just how many things can you throw at that disk in a second. Latency in terms of milliseconds. And if you're on a flash array, potentially microseconds, which is really cool. And then throughput, megs per second. Now, I look at this stuff generally in that order. Now, it's amazing. When you go graph this stuff with getting the information out of there, you can start to see some really, really interesting pictures. As my load goes up, what happens? You may actually hit an infrastructure bottleneck under the covers. In this case, it was actually virtualization HBA queuing backing up. This was a sequential write activity. They're doing backups to a target on an SMB3 share. And we found that the queue was actually backing up inside Windows, so it was suspending writing that until it could flush everything in there to disk. The workload kept growing and growing, and it was causing the performance to slow down. It's interesting. Picture says 1,000 words. You can do this today. Please do not do this on production during business hours. Bad things can happen. And don't do this after hours without talking to your storage folks to say, hey, I'm going to be running this. Now, don't give them an option not to run it, but run it. Just let them know you're going to do it. Get a window from them where it'll work. And get these numbers. I say don't do this during the day because bad things can happen. You can hit any one of these bottlenecks artificially, and as a result, choke everything else that's hitting the storage. That green bar that just popped up there, in this environment, that's where that customer was at today. They did not know that they were approaching a really nasty threshold where if the data volume continued to grow, they were going to start to fail. So we hit this proactively before it actually happened. It's pretty cool. Now, when I say spread out the workload, we want to try to eliminate hitting any one of those bottlenecks inside of the queue. So if I've got a hotspot in some of my data files, I may want to try to spread that workload out and get rid of some of these bottlenecks. Again, it's all about right sizing. It's all got to be scheduled. If we prevent something from getting backed up in one spot, everything else is going to continue to get better. So multiple data files, multiple file groups, multiple drives and windows, queuing inside windows. And if it's really light, if you look at the bottom with file group 2 there, maybe it should be placed on a single disk. If it's really light, it's not that big of a deal. All depends on your workload, but just think of this as an option for how to get rid of some of these bottlenecks. Okay, now I've got my metrics. You've got perfmon collected, or SCOM, or whatever. What do you do with all of that? That's where it gets interesting. So now it's time to go determine these runtime stats and the percentiles and the windows that you really want to analyze. Determine these thresholds where you feel comfortable at. What if, from a business standpoint, on this one mission-critical system, they don't want to see more than 20% consumed ever? Now you can prove it. In other cases, if it's like a utility server, maybe 60, 70%, doesn't matter. If it's a quarter-second longer runtime for some minor task, doesn't matter. Review those requirements. Go in and change the VM configuration. Find a maintenance window, turn the VM off. It's honestly like 5 or 6 clicks from the VM admin to go and change these configurations. Fire it up, test away. Power it off, test again. Makes a big difference. Don't make wild changes, please. Don't do what I did a while back, which was 40 cores to 3. It was kind of a drastic day, but they were in a lot of pain. If you have 3 CPUs and you want to go up, well, maybe go 1 and then go up to 6 and maybe 8. Don't go 3 to 40. Big deal. Test, 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 retest, please, please, please. Makes a big difference. Okay, so let's take a look at some of this. Okay, so I'm going to post out on my blog today a database schema here and some processes that you can use to actually go collect this stuff. So it's just a performance collection database. Use whatever naming convention you want there. So in this case, CPU performance, disk performance. I'm collecting a lot of things straight out of perfmon. Things like disk bytes per second read, disk queue length, which is not necessarily a red flag there, but it's not necessarily a red herring. It's a measurement of just the kind of pressure you got. Disk bytes per second read, disk per second read. So it gives you latency, it gives you throughput, and it gives you IOPS. Memory performance, stuff that I care about. Memory grants pending, page reads per second, available megs and windows, and a collection date. And I got network adapter in here just for fun. So a lot of different things. I got server, a bunch of stuff in here. Now, this script will go through and build this whole thing for you. There's some views in here to go get hourly performance. If you're on 2014, I've got another script that'll build you a column store index to actually go evaluate this stuff. There's a lot of stored procs in here. So let's get to business. Let me show you what this is actually going to do. It will be by the end of the day. If you look, just standard listing, just a way to go match, a server to an instance and really dive into it from there. So in this case, organization ID 5. These are coming from a couple different clients of mine, actually. Raw CPU stats, oh, I got a bunch. I got 40 CPUs on this one particular server. Right there, I can see I got 40. Now, if I just go look at my raw CPU execution data, I've got the CPU ID, so the individual CPU. I got the percent privilege time, percent processor time, percent user time, and when I collected it. So in this case, it was every 15 seconds per CPU for a business week. Okay, well, let's take a look at averages and maxes. Okay, per CPU core, I've now got average percent user time, and that's going to give you everything that you are running or that some background process from an admin, a third-party app, is going to be running. So in this case, 30%, 33%, 26%, pretty standard, reasonable performance. You start to add in background activity in there, and that you've got pretty decent performance. So it seems. Percent user time, minimums. Again, 0. because this thing is pretty idle occasionally. And then other times, 98, 99, 100% consumption there. The machine's maxed out, and that's all 40 cores. But you can start to trend this. In this case, I've got hundreds of thousands of records in there. Now that gives you min, average, max, pretty standard stuff. Now I can go through and actually look at my median by CPU over that threshold. You can start to see in this case, in this machine, all 40 cores, I was looking at 25, 11, roughly about 33% consumed. So you can safely say there, the machine wasn't being taxed all the time. On average, the workload was pretty good. So 40 cores, 33% consumed. I can probably go down a little bit and be comfortable that I can virtualize this thing in a smaller footprint successfully. Okay, but now let's go a little deeper. Percentile analysis. Now I've got a couple other machines here to show you. In this case, I've got two other machines. I got both of them with 16 CPUs. I want to go look at my percentiles of what's actually going on. Now, what do I mean by the percentile analysis? In this case, I generally love to do a 95th percentile analysis. What that does is if I have one little statistical blip, I don't have that errant bit of data skew what I really care about. Because if you've got a tiny spike here or there, okay, not that big of a deal. It's not anything to panic about. So a percentile analysis says 50% of the time, my CPU consumption is at or under some threshold. 75% of the time, 80, 90, 95, 96, 97, 98, all the way up to 100. And you can start to go see what's actually going on under the covers and what the trends really are. So in this case, on this machine, 85% of the time, I'm under 20% CPU utilized. 95% of the time, I'm under 57%. And it's just when you get near 100% do I actually get maxed out. So in this case, if something less than 1% of the time is actually consuming all of your environment, is that something to give you a whole lot of resources that may be slowing you down that other 99% of the time? I don't know. It's workload specific. It all depends. But I generally look at that and say, I probably need to go down a little bit. Now, same thing goes here. This other machine, it takes a couple of seconds to run because it's just a laptop. But same kind of trends. Pretty small, pretty reasonable. Come on. There we go. Same exact thing here. 50% of the time, 21%. But now, what happens when you take a backup at night or do index maintenance, things like that? All that's going to skew some of these numbers. What if I want to see what do I actually need for performance of resources during a business day? So I've got some other procs that I've included with this package. CPU performance business day by server. All you got to do is put in the server ID. And you can see here on this machine, on the business day, 95% of the time, I'm at 16% consumed or under. This machine had 16 CPUs. I could safely say you could probably go with 6 or less when it comes to virtual. If it's already virtualized, you can dial that back. Now, on the other hand, that really big machine that had 40 cores, let's take a look at how this thing is going to run. It takes a few seconds to run. So you can see here, 50% of the time, 35%. 75% of the time, we're under 62%. But now that last bit, that's fairly consumed. So again, the 40 cores, I may not necessarily want to dial this back too much. And in fact, the recommendation for this VM when we virtualize it in a month is going to be to keep the VM at 40 cores. Now, what if I want to see the CPU stats by interval? So on this week, what if I want to see the average CPU consumption per portion of the day? So I've got another query in here that goes and gives you all these metrics averaged by every 15 minutes of the day. So on average through the course of the week, by CPU core, what's it actually doing? So you can go chart and graph that. So on average at, what's that, 9:15 at night, these cores are fairly low utilized. Okay, well, I'm going to roll that up a little bit. I'll show you that here in a second. Memory consumption, same exact thing. Now, memory is a little bit harder because memory, what if I've got a lot of disk or fast storage, but not necessarily? So I don't do too much math here, but this gives you the metrics. What's your thresholds? What's your averages there? What really matters to you? Disk, same thing. In this case, this particular server had 18 disks on it because they were spread out. I want to get a percentile analysis by drive. So you can see, in this case, 50% of the time, 50% of the time while this thing was in use, I was at 3.3 megabytes per second or less being read at any given point in time. And you can see that last 5%, we went from 98, 115. Write performance, on the other hand, nothing, 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 nothing. No big deal. But if you look here at the latency numbers, generally speaking, I don't like to see anything more than about 25 to 40 millisecond latency on average, read or write, for anything virtual. You can see the storage responds pretty well until we get to that 99th percentile. Workload goes way high, disk responds poorly. In this case, this is about average. That's a pretty good, I know their environment pretty well. It's finely tuned. Cool. We'll hold the questions for the end if that's okay. Okay. I'm going to take a look here. This is their log drive now, the L drive. Similar setup. And you can see that we hardly did anything reading until that last 1% when it was probably doing a transaction log backup. But you can also see how the response time was here. Now you can go and cross and get all of these for all the disks, and you can start to really see what my hotspots are across the environment. Do I have a single disk that is just getting pounded 24 hours a day? Or is everything fairly idle and well balanced and well spread out? So I've also got another query in here for business day analysis of the exact same data. So by default, it filters against 8 a.m. to 6 p.m. Monday to Friday. It's just variables in there. You can go pass in through parameters. In this case, you can see that during the business day, 95% of the time we're under 114 megs, 81 megs read and write. I mean, it's a pretty decent environment, but it can also scale up when they go to do backups or heavy queries. Okay, so we've got raw data, but let's take a good look at what we can actually see and be able to hand over to a C-level person. So you can take this exact information, just drop it into a quick spreadsheet. So you can go see here, what's it really doing? Pretty straightforward. There's my percentile analysis, just like we looked at. Averages don't really tell us too much. I can do average cores per business day or just over 24 hours. And again, you can start to see trends in there. Doesn't really tell you too much. Bet this one does. Core consumption by hour and minute of the day. So what do you see here? 8 a.m., people come into work, consumption goes up. But it's, we're looking at about 40 to 50% utilized there. And then about 5 o'clock, people start to trickle home. By 6 o'clock, everything's quiet. And then at about 10 o'clock, backups kick in, nightly processing goes. And you can see the CPU goes up again. Disk consumption is exactly the same. You've got all those metrics I showed you before, but let's just plop them into some really interesting graphs. So now you can see here, by drive, what's my megs per second actually doing? And you can start to get a sense. Do I have hotspots? What is this one disk, the G drive here? That thing got hammered pretty hard. But what if it's all over the place? You don't know until you really look at it. Same thing, read and write. Same thing with the 95th percentile for the business day. Business day, average consumption is fairly high. And again, this graph down here is not linear. Memory, there's a bunch of values, same values before. Trended as your environment really sees fit. And then SQL Server wait stats. You can go through and do averages. You can do mins and max with those. Go start to see, where are my trends? What's really going on? Okay. gets interesting. There's no right answer for any of this. There's no magic bullet, but you've got the numbers in front of you. You can start to really see what's going on with the performance across the time intervals that matter, across the performance values that matter. Hard part here, this isn't a one-time process. Workloads change, databases get added, reports get added, applications get adjusted or upgraded. It's hard. What worked today just may not be the exact resource values that you need tomorrow. So what I like to do is, if your environment is fairly volatile, go profile this thing ongoing and do a right-sizing analysis, maybe once every couple of months. Or if you've got a major application upgrade or you're adding new stuff, go through and take a quick look at it. Once you get the hang of this, once you got the infrastructure in place, it doesn't take you that long to go through the analysis. So in a highly volatile environment, quarterly, sometimes more, sometimes less, but definitely do it every once in a while. Okay, summary. VMs, one size does not fit all. It all depends on the environment, where you're going with this stuff. Profile, performance test, go check it out. Now, but wait. That's a pain to do all of that. So I've got an announcement. This should be easier. So I'm working on something with my company to automate the VM right-sizing estimation of a production SQL server, both physical or virtual. I hope to have a beta out, hopefully by Christmas. And Merry Christmas. Because life's too short to do all this when you have fires to put out. The scripts will be available here by the end of the day. Keep an eye on my blog. I've got cards up here. If you're interested in becoming part of the beta test crew, come on up. Grab a card. I'll put you on the list, and as soon as we're ready, we'll send out an announcement. Are there any questions at all? And we actually have, since we were on PASStv, I'm going to open that up with if there were anything on Twitter. No questions on Twitter? Okay. Anybody have any questions? Cool. So step on up to the mic. There's a mic on each corridor here. Cool. I saw a couple of hands.
I'll volunteer for you.
Cool.
So the question is, how do you sizing the page files for the OS paging in VM?
Well, realistically, so the question was, how do you profile or how do you size page files? How much are you paging? Hopefully not much. It all depends. I mean, if you've got a smaller amount of memory, I'd probably leave it default. I don't like complexity in the environment. If it's huge, you probably don't need to be wasting the SAN space, so I'll generally knock it down, maybe half of the available memory, sometimes a quarter if it's a huge amount.
True, but sometimes somebody accidentally throw in a dumb query. Select start from with 9 billion rows.
Yeah, and again, it all depends on performance profiling. What are you actually using? What are the maximums that you hit? A lot of times, I'll put it on a drive on its own, and that way, if for some reason we see that thing ballooning, through alerting and detecting, we could see it and potentially get in front of it.
It does, but I mean, there's no standard back into NT40 where you have double the size of memory, yada, yada, yada.
It's one of those, it really all depends on workload. I don't have a great answer for you. It just depends. Basically, the bigger the amount of memory, the more I would go and dial that back a little bit. Thank you.
What are your thoughts about these storage systems that they are actually automated to your system? I was accustomed to this storage array where you have tier 1, tier 2, tier 3, and tier 1 is the fastest one, and tier 2 is not so fast. So I was told by the storage guy, like, this is totally automatic, right? So the tier 1, we just don't have a lot of space. So I was able to convince the guy to put 10 DB files there. So everything else is pretty much, like on a regular long, that it is mixed, and the Dell compelling internally supposedly just handles and move the stuff, you know, depending on the workload.
Yeah, and tiered SANs work great, but the question is, can you do anything with that configuration? Not really. What's the latency like inside your VM, your SQL server itself? And you can measure it per disk, per data file and log file. If that latency is pretty high, talk with them. You know, if you need to scale out, because what if the bottleneck is not actually at the SAN? What if it's actually in the Windows disk controller queue? If you add more virtual disks and scale out, even though it's auto-tiering under the covers, you may be able to break through that bottleneck and reduce it to further down in the stack.
Okay, so isolating that by one point or file group basically does nothing, because everything is just like on the same storage array.
Yeah, but even if it's the same storage array, even if it's the same set of disks, there's queues further up in the stack. You have multipathing inside the hypervisor, multiple queues inside Windows. You want to use all available channels to get to the array, even if the array is not the problem. You may have a problem further up in the stack.
Okay, cool. Thank you.
Cool. Cool. Any other questions?
Yeah. Do you still recommend that you take the NUMA setting for your VMware boxes and put them on NUMA boundaries?
So the question was for NUMA alignment of a virtual machine, do I recommend actually going and setting that along the boundaries? And absolutely. Yeah. Just in this case, it was just perfmon. I used the Midnight DBA package to go extract it out of a BLG file and load it into a database and put it into those staging tables. Yep, exactly. Yes, ma'am. Or did you have a question?
Do you allocate, if you've got 16 gig of memory for your server, do you allocate all of that available to SQL Server, or do you save a little bit just for the server itself?
Oh, you got to save a little bit for the headroom of the OS. Jonathan Cahias, who's actually here at the show as well, he's got a great formula for computing that value, and that's assuming there's nothing else going on that machine at that time. Go check it out. It's at his blog at SQL Skills. On average, it lines up to about 75% of the available memory for the SQL Server buffer pool. But you know, just what I do is generally go conservative there, and through perfmon, look at the amount of free memory available. Yes, sir?
Do you still need to do the disk alignment when you're doing VMs?
Absolutely. It's one of those, do you have any 2003 machines that you're handling right now?
Yeah, we do.
I'm sorry. If it's a 2003 machine, go check disk partition alignment, because actually that's a great question. I generally haven't had to speak too much to that, but if it's misaligned inside the VM, that gets magnified with every VM that you've got, and you're hitting the SAN that much harder. It's a destructive operation to go fix it. Windows 2008 by default fixes that automatically. But if you still got a 2003 machine, go check that out. So I'm actually giving another talk on Friday at 4 o'clock about virtualization of SQL Server performance tuning, kind of at a holistic level. So hopefully you can see me there. Yes, sir?
In your sample code, you have the drive letters. Do you have for mount points as well?
The code itself will handle, if it's either a mount point, you actually define it inside the script, and it just pulls it in.
Okay.
I think a lot of these stats, they're really caveated because anything you're capturing down at the guest level, you've got weights going on at the hypervisor level. The guest is completely unaware of it.
Exactly.
So some of these weights, they're going to really be skewed. You don't really have a way of, that's kind of one of the things I came here for, but I'm not getting there now at this point, because I still feel like a lot of these stats you're gathering, they still don't show any time that guest is not actually active.
Yep. So the comment is, and he's exactly right, every one of these performance stats that you see inside the virtual machine can be skewed because they can be off. Now, the skew is not that huge. The skew is not major unless there's a significant problem under the covers. But that's why I stress so importantly, get access to your hypervisor, get access to those management tools. Now, you know, if it's a VMware environment, I can give you the queries to go mine that straight out of the vCenter database. With Hyper-V, it's a little more difficult, but you got to overlay all of that. But as long as you've got access, you can go see, is this thing off the charts, or is it fairly well configured and idled?
Is the physical CPU, on the physical CPU side, if these guests are switching out, are there concept switches going on the physical CPU that's pulling these?
You know what? So the question was, if the physical CPU is maxed out, yeah, let me give you a handful of cards here.
Cache
So the question was about CPU cache. Honestly, these things are so fast nowadays that it's not necessarily going to be the biggest issue anymore. Usually you run out of memory before you run out of CPU. Excellent. Are there any other questions? Thank you. Cool.
Do you know if vMotion can cause connectivity issues?
Yes.
It can?
If the environment is not configured properly. If everything is great, you won't get an issue.
Connectivity issues, and that's the only thing I can think of that makes any sense.
Okay. Yeah. So let me do this.